Hello, and welcome to openFrameworks Audio Programming Tutorials number 2. Today we will be building an additive synth and discussing important elements of object-oriented programming. But first, a brief background on additive synthesis. As stated in the computer music tutorial on page 134, additive synthesis is a class of sound synthesis techniques based on the summation of elementary waveforms to create a more complex waveform. Fortunately for us, we already learned how to create an elementary waveform in the previous tutorial, namely a sinusoid. Let's add some things together. First, let's start a new project. Go to the project generator. We'll call this Additive Synth, and we will not need any add-ons. As we did last time, let's go ahead and get rid of some functions we won't need. So everything up to mouse moved, and we'll get rid of key pressed and key released. Let's add an exit function, and let's add our audio callback function. Okay, and let's make our CPP file correspond. Okay, and let's grab our audio callback function, copy and paste. This time, let's store our sample rate in an integer. And I'll be running 48,000 samples per second. As we've done before, set up our audio stream. 2 output channels, 0 input channels. 48,000 samples per second, 512 buffer size, 4 buffers. Okay, let's go ahead and run the program now just to make sure everything's fine. Great. Okay, so as we did last time, we'll need variables for our oscillator. So let's make a float, frequency 1, float phase 1, float phase inc 1, and float amplitude 1. I named them slightly differently this time because we will have more frequencies and phases and amplitude variables. For now, let's just build the first oscillator. So frequency 1, let's set to 200 Hertz. Phase 1, we will set to 0. Float phase increment 1 will set to 2 pi times frequency 1 divided by sample rate casted as a float. And finally, amplitude 1 will set to 0. Let's just do 1.0. Alright, let's add our for loop to our audio channel, or our audio stream. For int I equals 0, while I is less than the buffer size, increment I. Left channel is a buffer at point or at index I times number of channels plus 0 equals current sample. Buffer for the right channel at I times number of channels plus 1 equal current sample. Again, this will be another monophonic synth. Let's make our current sample float current sample equals 0. Set it to nothing to start, and we should be good with that. Alright, so current sample is equal to the sine of phase times amplitude. Now we need to increment current sample. Alright, I'm going to go ahead and fix this now. I forgot the E on phase increment, but I should include that. That was a mistake. Alright, now if we play this, we should hear a full volume sample. Something I typically do when I'm working is to scale the volume down at the very end of the chain. Current sample equals current sample times 0.1. Nothing. That's interesting. Okay, why not? Ah, there it is. Okay, so not current sample plus equals phase increment 1. It's phase 1 plus equals phase increment 1. We should hear a 200 hertz sine wave. Sounds 200 hertz to me. Alright, so now let's add two more sine waves. So to do this, we might copy and paste this code and then rename. So frequency 2, phase 2, phase increment 2, and amplitude 2, frequency 3, phase 3, phase increment 3, and amplitude 3. A bit tedious for sure. Okay, so let's copy this to make sure we don't spell anything wrong. Alright, so frequency 2 equals, let's make that 400 hertz. Phase 2 equals 0. Phase increment 2 equals to 2 pi times frequency 2 divided by, cast it as a float, our sample rate. And let's make the amplitude 1 divided by 2, or 0.5. Let's make it like this. not as efficient, but it'll make things clearer later. Alright, add the same thing for the third oscillator. Let's add another 200 to that, so let's make it 600 hertz. And let's make this amplitude 1 divided by 3. Alright, that's all set up. So now we need to not do this the same way. This is fine, but now we need to add the current sample to the current sample. So we could do this. Current sample equals current sample plus our new oscillator, phase 2, times amplitude 2, phase 2, plus equals phase increment 2. However, that's a little unclear. I don't quite like that. We discussed this briefly in the last tutorial, but we can just do current sample plus equals, and that means the same thing. Great, and I think that's a little more clear, and we'll use that a lot later on. And then let's add a third harmonic. Current sample plus equals sine of phase 3 times amplitude 3. Phase 3 plus equals phase increment 3. Alright. Oh, something is not right. Oh, I capitalized phase. Case matters. Okay. And it's still scaling down by 0.1 at the very end. And let's go ahead and change this. Current sample times equals 0.1. Again, that's the same thing, it's just written a little more concisely. Alright, now we can hear those harmonics. And in this case, they are harmonics. Since they're integer multiples of the fundamental frequency, they're considered harmonic. If they're not, they're considered partials. Oh, we heard a change there. So the difference between a partial and a harmonic is that a partial does not have to be an integer multiple of the fundamental frequency. But it can be. That doesn't make it not a partial. But a harmonic has to be an integer multiple of the fundamental frequency. So you heard a shift in pitch there. That's happening because that should have thrown an error, I would think, but because our phase increment is not very precise. We're not using a precise enough value for that. So let's go ahead and introduce a new type, which is called a double. A double is twice the precision as a float, so it's a special kind of float. Alright, so phase 1, double, and that's 64 bits typically, not always, but typically. Double. Alright, now let's make sure we're not getting that irregularity. Sounds good to me. Okay, so you can likely see where this is going. This is very tedious and not going to work much further than making 3. Typically, you'll need around 24 harmonics, give or take, to represent a reasonably bright tone in this method. So making this 24 times by hand is absurd. So, that's fair. If only there was some way to add a new oscillator that didn't require all the tedious naming and typing. And this would be the class. Alright, so I'm going to leave this there for now and make a new class. A class is kind of like a recipe. if you're a super collider programmer, this will be very similar to a synthesis definition or a synth def. We're not going to make this class where we're making this. Your openFrameworks app is actually a class of its own. You can see here. So let's make a new class. We'll call it Oscillator. Bracket, and whoa, what happened there? Notice the semicolon at the end of the class. All right, and it seems happy. It turned green. So members of a class. This let's back up a bit. A class can store functions and it can store variables. It is often confused in C++ with a structure which can hold functions and variables. They're basically, from our point of view, the same thing. Historical context kind of makes you use them differently, however. The rule of thumb I've seen throughout various programs is to use classes to store data and functionality, and just use a structure to store data. Of course, you can do whatever you want, but we'll stick with tradition here. And members of a class can be public or they can be private. So if we want to access something outside of the class, we want it to be public. If we don't need to access it, it should be private. So we'll need a function to set up the oscillator and a function to get the sample from the oscillator. So we'll say public void setup, and this will take floats for frequency, a double for phase, and what else do we need? A float for amplitude. All right, we'll just do this the other way, and let's make all the following members public. And private. So you can see in our openFrameworks app, it does it this way, where it says public with a full colon, and everything you list after is a public variable. There is no private here. We can add one like this. Once we say private, everything following that is considered to be a private variable. All right, so this is a public function, and we'll set up our oscillator here, and we also know we will need a function to get the current sample. So make a float, get sample, we'll call the function. We don't need any arguments, so we'll just leave those closed. Great. So whenever we call this get sample function, it will return a float. This is a good time to mention void. Whenever we call setup, it returns nothing. That's what the void type means. And you'll notice we use that a lot. And I decided to wait on that explanation until we use something else. So in this function, we return a floating value, which is nothing yet. All right, so let's add our members. We need frequency, phase, phase increment, and amplitude. Float frequency, float, let's do a double phase increment, and finally float amplitude. And let's also store the current sample. Great. So the get sample will be fairly simple. Well, first let's do everything else. Depending on the programmer, I see underscores in between these argument names, just so you can use the same name that's the most logical and not confuse it. So in the setup function, we'll have frequency equal to frequency that's given. Let's do phase equal to the phase that's given. And amplitude equals to the amplitude given. All right, and with this information, we can actually, one more thing we should take is the sample rate. And we might as well store that. Okay, so sample rate equals the sample rate given. Alright, and we need to assign the phase increment value just as before. So phase increment equals 2 pi times the frequency divided by cast as a float sample rate. Alright. You know, now that we're using this, we might as well cast that as a double, since we're storing phase increment as a double. Okay, so one last thing. Let's just go ahead and set the current sample to 0. Alright, so this is our setup. It's very similar to what we have here, but we'll actually be passing in some values. Let's go ahead and get rid of that. Alright, so the get sample function will look a lot like this. In fact, I'll just copy and paste that for a reference. Alright, current sample equals the sine of the phase times amplitude. And then the phase is incremented by the phase increment. Great. And as I said before, when we call this function, it's going to return a float. So we need to use the keyword return and then return current sample. And that should be good. Okay. So let's go backwards for a second here. Get rid of all that. Get rid of all this. Should be good. And now let's make an object from our oscillator class. So if the oscillator is the recipe, the object is what we cooked with that recipe. So let's make a new oscillator and call it my oscillator. Very creative that way. And notice this turned green. It knows it's a type. That means it recognized it as a type, which is good. All right, so take my oscillator, put it here, and now we can set it up with the setup function we wrote. Setup, and notice it already tells us what we need to give it. That's one of the benefits of having an IDE like Visual Studio or Xcode. So let's give it a frequency of, let's do 200 hertz. Give it a phase of 0, an amplitude of 1.0, and a sample rate of sample rate. And it looks happy. So now we need to get the current sample. So current sample equals my oscillator dot get sample. Whoa. All right. And if we had success, this should play a 200 hertz sine wave and scale down a bit. Ah, good. That's great. Okay. So that doesn't seem like less work yet, because we had to write all of this just to get that. And that's, not too bad. But let's just try something else. As I said in the last tutorial, an array is a list of common data types. So let's make an array of oscillators. Oscillator. Let's just get rid of the my. Oscillators. We'll just make it plural to demonstrate that it's an array. And let's make 12 of them. Alright, so now we have 12 oscillators. Better yet, let's go ahead and get rid of this. Let's use a variable to store how many oscillators we have. C++ is a little picky about what variables you put inside of an array bracket. So we want a static constant integer. And we'll say the number of oscillators equals 12. And this should all clear up. There we go. And put this here. Don't worry about this. This is just our promise to C++ that we won't be changing this value. If you get rid of that, you will get an error here. Okay, it doesn't trust you well enough. Alright, so now we need to set up all 12 of those oscillators. So instead of writing each one independently, let's use a for loop and do it all as fast as possible. For int I equals 0, while I is less than the number of oscillators, increment I. Okay, and then oscillators, your collection of oscillators, at I, so the 0 through 11, dot setup. We'll give each one a frequency, a phase, an amplitude, and a sample rate. As I said before, let's make these harmonic. So let's make each frequency an integer multiple of our fundamental frequency. So let's make our fundamental frequency 200, and we'll take that times I plus 1. And now we're doing I plus 1 because I's first value will be 0, and that would make our first oscillator 0 hertz, which is not ideal or audible. Okay, and then the phase, we'll start them all at 0, and we'll make the amplitude 1 divided by I. So 1 divided by, actually, we'll cast this as a float, I plus 1. Here, the plus 1 is even more important because if we did not, we would be dividing by 0, which will immediately crash our program. So we don't want that. All right, and finally the sample rate, which is sample rate. What is making this unhappy? Expecting preceding parentheses of a parent call must have pointed to function type. What? All right, let's do some troubleshooting. Let's float frequency. Why is that having a problem with this? Oh, duh, okay. So the problem is I never put the multiple sign there. So we want to multiply those, and then we're happy. Simple enough. All right, so with 3 lines of code, we've set up 12 oscillators. Getting better. All right, so we want the same kind of thing in our audio out loop. So we don't want to use I because we already used I in here. So it would be confused about which I we're talking about. So int j equals 0. J is less than number of oscillators. Increment j. Now we'll set current sample plus equals oscillators at j, so we make sure we access the right oscillator, dot get sample. Great. And so just to make sure we're clear, this get sample was made in our header file. So it's just calling this information based on the setup information we gave it. It makes our code nice and clean for our audio loop, which you definitely want. So we should have 12 oscillators, and they should all be scaled based on how high of a harmonic it is. That sounds about right. All right. Well done. Okay, so as we did last time, let's set our X mouse position equal to frequency and our Y mouse position equal to amplitude. We'll have a little trouble doing this because, as you can see here, frequency and amplitude are private members. So we can make functions for this. Void, because we're not returning anything, set frequency float freak. And then we'll set frequency equal to whatever we give it. And when we do that, we also need to change the phase increment value. So phase increment same as before. 2 pi times frequency divided by, cast as a double, our sample rate. And it should be happy after that. Oh, I forgot the E once more. Alright, so this is how you can access a private member of your class. Alright, and let's make one for amplitude while we're here. Void set amplitude float amp. Amplitude equals amp. And all should be well. Great. Our class is getting a little more sophisticated. Alright, so now we need something different than we had done before. So every time you move the mouse, we need to go through all 12 oscillators. So for int I equals 0, I is less than, while I is less than number of oscillators, increment I. Before we get into that, let's make a temporary frequency just to make our code cleaner. Temp freq equals, we'll map our x value from 0 to the width of the screen to 240 and 2000 hertz. All right. So we're not going to set every harmonic to the same frequency. That would defeat the purpose. So let's see, oscillators at I, set the frequency, and we'll set that frequency to be our temp freq, or temporary frequency, times I plus 1. Great. And in our function, we already took care of the frequency increment, so we don't have to worry about that here. And let's do something similar for the amplitude. Float temp amp equals of map y from 0 to the height to 0, 1.0 to 0. Remember to reverse that because of the dimensions of the screen. Alright, and we'll need another for loop, and I equals 0. I is less than the number of oscillators. Oh, not that. Increment I. So, one quick thing, notice we use I twice here, but I said we couldn't do it here. The reason we can do it here is because this for loop is not inside of this for loop, it's after it. So once this is done, it forgets all about that I value. But here, our this where we had to use J, that's actually inside of this for loop. So it already has an idea of what I is supposed to be. Alright, so now that we're going through these again, oscillators at I, set amplitude. And we'll set that amplitude to our temp amp times 1 divided by float I plus 1. A lot of parentheses happening there. Okay, so now when we move the mouse, we should be scaling the frequency and the amplitude. Okay, that's not bad. Finally getting some timbre going. And that's basically the end of the tutorial. The rest of this will just be housekeeping. We're going to put all the same code we made here in a separate document. This might seem like overkill, and I would agree that it is, but we will need to know how to do this, and we might as well start now for later tutorials. So if you're on Mac OS or using Xcode, they have a document wizard that works, and you can just right click on your source code or your source folder and click add document or something like that and make a new document. I tried to use the class wizard in Visual Studio, and I had trouble linking the file. When I tried to compile the project, it had no idea the file was there. So I'm positive there's a good way to do this in Visual Studio, but just to avoid that kind of trouble and headache, let's do it the old-fashioned way. Let's make a new document, or a new file, and that'll open a dialog box. We want a Visual C++ file, and let's start with the header file. Let's go ahead and open that, and this will just open that file for you, and then you can save as, and we'll call this audio tools. And I'll call it something more broad, or I call it something broad because we'll be adding to this in later tutorials. So go to My Apps. If I remember what I call this, Additive Synth. We'll save this to our source folder, and I'll call it Audio Tools. Save. So now we have our new header file. Now we need another new document for a CPP file. So new file, CPP, open, file, save as, audio tools.cpp. Alright, so this is the annoying part, and I'm not sure why this is, but this will not be linked to your project yet. We need to go to the same folder, go to your apps, My Apps, Additive Synth, or whatever you happen to call this particular project, go to your source folder, and click on both of these, and then bring them into your project, and drag them into your source folder. Alright, now they are linked, and now it knows where to look for those. Alright, so if we go to these documents, they're totally empty. Well, that's not true. We have pragma once here, which I will go ahead and delete. Okay, I'll tell you why I deleted that in a moment. So we need to relocate this information into this separate document. So I'm going to go ahead and take all of it and just copy and paste it here. This is not ideal. First we need to add a couple things. Let's add some preprocessor stuff that we'll need. If not defined, define, and then end if. Alright, so we'll call this audio, oh, it's already called that, audio tools underscore h, audio tools underscore h. Why an underscore, not a period, I'm not sure, but that's the way of the world, I guess. Alright, and let's also, and you see it's complaining, it doesn't know what 2pi or sine means. To do that kind of math, you need external libraries, and when we're using openFrameworks, we already have those included. So let's make sure we include those here as well. So let's include openFrameworks by saying include of main.h. And then you'll see it will stop complaining about 2pi and sine. There we go. Alright, and the reason you need if not define, define, is if you try to redefine something, the compiler will either complain or just totally bail on you. C++ has this fancy feature called pragma once, and that takes care of it for you. Saves you about 2 lines of code, but I just don't use that because I like to keep this ready for C, and this will work in C. This will, if I'm not mistaken, not work in C. So add the extra 2 lines just so you don't have a headache later in your life. Alright, great, so we're almost there. We also have this audiotools.cpp, and this is where we should put our functions. So let's go ahead and do that now. Void setup, put our setup function there, and let's take our get sample function and put our get sample function here. Alright, we're going to get a lot of complaints, but we'll fix those in a moment. We'll get rid of this information here and just keep the name of the function. Alright, so it's saying we're not using those, but we'll fix that. Oh, we have two more. Alright, we could leave these here and it would be fine, but let's just prepare for the future here. Alright, so it doesn't think we're using them because we haven't included our oscillator header here. So void oscillator, and then it should be happy. Nope, not yet. We have one more thing to add. This is just some stray document. It has no idea what it's a CPP of. So we need to include, what do we call this? Audio tools. .h, and now it will know what's going on. Finally, give it a second though. All right. Make sure it's happy before we leave. All right. So we have stored all this functionality, which granted it's not much, into a separate document. So now we have our main openFrameworks document, and you notice it no longer knows what an oscillator is. This information used to be right here. So instead of writing the class there, we just tell it to include the class, or include the file. And then it should make this very happy. Look at that go. Okay. So scroll down here, everything's fine. Let's go ahead and try it out. Hey, that's fantastic, and that'll wrap it up for today. So in conclusion, we've made a class that stores an oscillator, got information from that oscillator, and made an array of those oscillators. And we've also overcome the burden of working with different documents, which not necessary now, but again, we will need this very greatly in the future.